Hey there guys, welcome to these AS Level Maths past paper exam questions on trigonometry. Here we are doing a mix of questions on identities, equations and graphs. I have enough questions, I think, at the moment to make 3 of these. I recommend doing them all because trigonometry is a massive part of A-level maths. Alright then, let's go. Okay then, first up, if you download the PDF from down below, I've also made this page with both trig identities you need to know for AS Level Maths. Okay then, first up, state the interval for which sine of x is a decreasing function for x between 0 and 360 degrees. Okay, so a function is increasing when its gradient is positive, decreasing when its gradient is negative. So if we sketch him, sine of x looks like that. Now, the gradient is 0 at 90 and 270. Now between those 2 points, the gradient is negative, so the interval is x is strictly greater than 90 and strictly less than 270. But to solve the equation tan squared 2 theta minus 3 equals 0, giving all values of theta between 0 and 360 degrees. Okay, so the first thing we need to do is get tan 2 theta on its own. So I'm going to add 3. So, tan squared 2 theta equals 3. We're then going to square it. So, tan 2 theta now we need to be very careful here, very important with trig. When you square root, you get plus or minus the answer. So, tan 2 theta is plus or minus root 3. Okay, so now we have 2 equations to solve. So, first up, I'm going to do tan 2 theta is equal to positive root 3. Okay, so we can get to theta by taking the inverse tan of both sides. So we will get 2 theta is equal to 60. Now that tells us then that theta is equal to 30 degrees. Okay, now tan of theta has a period of 180 degrees. That means there is a solution every 180 degrees. But we are dealing with tan of 2 theta. So 2 theta makes everything happen twice as fast. So it squashes the graph together. So tan 2 theta has a period of 90. So to get the other solutions here, we add 90. So the next one is 120. Then 210. And then 300. Now the next one would be 390, but that is outside of the interval. So we have them all in there. Okay, and then we need to do tan 2 theta is minus root 3. Okay, now if we inverse tan, we get 2 theta is equal to minus 60. Now that would lead us to theta is minus 30. But that's not in our interval. So theta equals minus 30 is not valid. Now, as with the one on the left, to get to the other solutions, we just add 90. So, we're going to actually get then that theta is 60 150 240 and finally 330. So, 8 solutions. Good times. Okay, number 3. It is given that cos of 15 is 1/2 square root of 2 add root 3, and sine of 15 is 1/2 square root of 2 minus root 3. We want to show that tan squared of 15 can be written in the form a add b root 3, where a and b are integers. Alright, so for this we need to know that tan is sine over cos. So tan of 15 is going to be 1/2 square root of 2 minus root 3 over 1/2 square root of 2 plus root 3. So the halves cancel out. So we have root 2 minus root 3 over root 2 add root 3. Now we want tan squared, so if we square both sides, we can get tan squared 15 is 2 minus root 3 over 2 add root 3. Okay, now all we need to do here then is rationalise the denominator. So, we're going to multiply the top and bottom by 2 minus root 3. So, up on top, we're going to get 2 times 2 is 4, minus root 3 times minus root 3 is positive 3. So we have 7. And then we're going to get minus 4 root 3. Now on the bottom, we get 2 squared minus root 3 squared. So that's 4 minus 3. So our final answer is 7 minus 4 root 3. Okay, next up we want to state the number of solutions to the equation tan of 4 theta equals 1 for theta between 0 and 180 degrees. Okay, so again, tan theta has a period of 180 degrees. So, tan of theta would have one solution in this interval. Tan of 4 theta has everything happening 4 times faster, so it's squashed together. So there are 4 times as many solutions, so there are 4. Okay then, final question for this set, and it's a tricky one. So ABC is a right-angled triangle. The point D is on hypotenuse AC such that AD is equal to AB. So, first thing I would do is put that onto the diagram. So, like that. We're then told the area of triangle ABD is equal to half the area of triangle ABC. Our job is to show that tan A is equal to 2 sine A. Okay, so quite tricky. Let's deal with, first of all, making the notation a lot nicer than using A, B and A, D, etc. So, we know that A, D and A, B are the same length. So let's call them X. Now, we're also going to be dealing with tan A. Now, tan is the opposite over the adjacent. So, we're also going to need side BC. Let's call that Y. Okay, now from that we can say that tan A is Y over X. Okay, now remember that. Okay, now let's deal with these areas. So the area of ABD well, we have an angle and 2 sides coming out of it. So it's 1/2 times x times sine of A. So it's x squared sine A all over 2. Now the area of ABC is just base times height over 2. So that's just xy over 2. Okay, now we are told the area of ABD is half the area of ABC. So, we can say then that x squared sine A over 2 is equal to 1/2 of xy over 2. So that's xy over 4. Okay, now if we multiply through by 4, then we get 2x squared sine A is equal to xy, and then divide through by x squared, we get 2 sine A is equal to y over x, which, remember, was tan A. Done. Given part B wants us to show the equation as two solutions for A between 0 and 90 degrees. Okay, so we had tan A is equal to 2 sine A. So first up, get everything on the same side. So tan A minus 2 sine A is equal to 0. Now tan A is sine A over cos A. Okay, now if we multiply through by cos A, then we get sine A minus 2 sine A cos A is equal to 0. Now that has a common factor of sine A, so we can then write this as sine A times 1 minus 2 cos A is equal to 0. Now, from that, we get either sine A is equal to 0, which would tell us A is equal to 0, or cos A is 1/2, which would give us A is 60. Given part to state the solution which is appropriate in this context. So A is an angle in a triangle. It cannot be 0, so it's 60 degrees. Okay then guys, that's it for this set. On to set to go. Hope to see you there. Take it easy. Take care.